Okay, this is my AI homework 2, the Chicago game. Um, so I'll just play a little bit here to show you how it works. So at the beginning here, we select the difficulty. I set it between 1 and 5 because any more than that, it's going to take an hour for every response, if not longer. So we'll play it on 2, so it'll go pretty quick. Okay, so we'll see that it is my move here. We see the board comes up and all the spaces. So we'll put a piece in 5, and we can see that he put a piece in 1. So then I'll put another one in 5. He'll put 1 in 2. I'll block him off and put 1 in 3. And so we can see that as we play through the game here, that he's making smart decisions. While they're not the best decisions because this is only level 2, it's still, you can see that he's still placing pieces quite intelligently, and he's gaining points even though I'm beating him right now. If you put him on level 3, he's pretty difficult to beat. So I'll do a quick run through of how this works. So here's the actual board here. So we have the constructor for the board. Then we have different methods for either a human placing or the AI placing. It's just the difference between O's and X's. So it checks to make sure that that space is available, and it goes through. It's a 2D array, so it will go through and find the slot that you selected. Then we also have some methods that if the human can place or if the AI can place. These are used by the min-max algorithm. So this will return a whole new board with a whole new 2D array. So this is for our possibles when we go through the tree. Then we also have our get score methods where we calculate the score as indicated in the assignment. Then we also have can place, which this is just a catch-all method to say, is there any more open rows in this column? Can we place something at that index, or is it completely full? We also have a game over check. And we have a toString method that prints out this nice little array here. So we have a node class. This is what all our min-max algorithm is going to use to go through. So the nodes have a parent node, a current state of the board, a score for that node, which this score is actually calculated below in a method down here. This is actually the AI score minus the human score, not just the AI score. So we can see which way is best, so the AI doesn't go in a direction that, even though it gives itself good score, would cause the human player to win the game. And we also have which level it is in the tree, and then we also have which slot this piece is going into. This is just a check, so at the end we can say, okay, slot 3 was the best outcome, so let's put a 1 in slot 3. So now we'll actually go through the min-max algorithm here. This is so we're going to get the an array list of nodes. So we actually call the algorithm first. This is a recursive algorithm. So this is where this just gets the root node, creates a root node from the board state. Then it's going to get all the children, the possible outcomes from the current state, and it's going to go through, and then it's going to call min-max. This will go through, and it will go until the selected depth, which is set as the level at the beginning. The level at the beginning, it goes to the depth times 2, so it'll go through min and max per each level. So we also go through here. We got so then once it hits the correct depth, it's going to fill in the scores and then recursively make its way back up the tree. And then back here in the min-max call, after we go through call min-max for all our nodes, now the scores should be populated for all the children node of the root, and then we'll go just through those nodes and we'll find which one has the maximum score. We'll return it, and then we'll play the game, and we'll return, and then we'll wait for the human player to make their next move, and we'll call min-max all over again. And that is the overall how this algorithm and program works.